4.2 Summer Jobs in Unit 3, Lesson 4. Second part to this, Elena and Jada each make money by helping out their neighbors. Elena babysits. Her earnings are given by the equation y equals 8 and 40 hundredths x, where x represents, this is a big deal, x represents how many hours she works, and then y represents how much money she earns. Jada is earning $7 per hour mowing her neighbor's lawns. Both of these situations give us a lot of information. And the questions that we can answer with this are really limitless, but I think since it's talking about money, we're all probably a little more interested in it. So what we want to do with this as far as our duties or our responsibilities, the first thing we need to do is figure out who makes more money after working for 12 hours. How much more do they make, and explain how you know. And then we're going to find out what is the rate of change for each situation and what does that mean, and how long would it take each person to earn $150. Explain or show your reasoning. To get started with that, I think that it would be easy for us to go ahead and take a look at either representation. You might be more comfortable with drawing a table, or you might be more comfortable with making a graph. I'm going to do both to help you to work through this problem. The first thing that we want to do is on our table, we're actually going to need to include another column. And the reason for that new column is because we have two different people. We have Elena and her information, and then we have Jada. And by adding one more column, it saves us from having to draw an entirely new table. So I'm going to just go ahead and do this right here. Put this table in. And what happens is this new column represents the X, or the input. In this case, we know that the input represents how many hours is worked, right? And then how much money is earned. So we know that this is hours. And then for the other two of them, if we kind of think about this on a bigger table, this is money earned. Now, something that would be helpful for both of us, or for us, is to recognize Elena's equation is y equals 8 and 40 hundredths x. And Jada doesn't have an equation, but I think that what we can do is model an equation right off of what Elena does. If Elena is getting $8.40 per hour, we know this is both about money, then we can model that and say, well, Jada is getting $7 per hour. And we can simply look at their inputs. If both of them work for 1 hour, Elena is making $8.40. And Jada is making $7. If they work for 2 hours, we can see $16.40 versus $14. And if you remember what I talked about in the last video, we have these decimals and we have to be able to make a graph, or we have to be able to create something bigger and better. One of the numbers that we can always use in this case, this is hundredths. If I multiply this, every time I multiply by 10, I move a decimal place over. So if this one, if I want to multiply by a place value of 10, or working for 10 hours, I know that Elena would be making $84 in 10 hours, and Jada would make $70 in 10 hours. You are going to have to figure out on your own how much they made after 12 hours. So that one's up to you. If I'm looking at a graph, to be able to do this, I need to use the same information that I have here in the table, and I need to recognize that X is hours worked, and Y is going to be money earned. Appropriate intervals for this, well, we can see that after 10 hours, we have 84 and 70. So we need to think about something that's pretty large, but we also need to be thinking about something that's not too large. If I go down here with these other two pieces, or with these inputs of 1, 2, 10, and 12, I can think about here along the bottom, I can go ahead and go by ones and just say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I can call that by twos. Either one will be acceptable, but I have to model my other y-axes more appropriately to these outputs. I think in these outputs, modeling something that's going to be maybe by fives, this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. I'm going to go to 85. It's probably a little bit small of an interval, but it will definitely work. But here's a little secret. You don't have to write the labels on every single one. If you just get it started here, we can call it 30, 40, 50, 60. 70, 80. And here on the bottom, we counted all these by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we just go ahead and start graphing. But remember, there's two different girls here. So that means that there's two different sets of data, two different equations, which means I'm going to use two different colors to draw two different lines. What we know about both of them is that if they earn, we're going to make Elena orange and Jada pink. If Elena and Jada both work for 0 hours, guess what? They get $0. So Elena needs to go up here after 10 hours to $84. All the way up here is 80, 84, somewhere really close to the top up there. And we'll go ahead and draw her graph. And then let's go ahead and put Jada's information in there. Thankfully, Jada's information is a little easier. 10 hours, $70, right there. So comparing the two of them, it's pretty clear who makes more money. It's pretty clear that Elena is making more money. But the question is not that. The question is, how much money did they make, each of them make? Explain who made more money after working for 12 hours. That's pretty obvious that Elena makes more money, but how much more money did she make? And explain how you know. You're going to have to talk about using your process for here and here. You can't just simply say she worked more hours or she earned more money. Be more specific with your information, saying that her constant of proportionality, or in this case, since we're talking about her money, her constant rate is more, or is more money, and or is this much more money. Be very specific. So when we talk about rate of change, let's look at that rate of change. We said orange is Elena. So Elena, her rate of change is this. For every 1 hour that she works, she makes $8.40. So her rate would be K is equal to 8 4/10. What does that actually mean? Well, in this context, I think I've said it enough now. Elena, did I spell her name right? Elena makes $8.40 per hour. That's what her constant rate means. And then we know that Jada is making K is equal to 7. That's a pretty simple one there. And so what is she making? Hers is $7 per hour. Now, how long would it take each person to earn $150? Explain or show your reasoning. I think that a table and a graph takes a lot of time. I think you know that too, especially looking at this now. And we recognize that an equation may just be our quickest route to get there to the $150, but that's not the only way to do that. So I'm going to get you started. Elena's equation is y equals 8 4/10 times x. If we're going to earn $150, we can simplify, or we can take this value right here and recognize that that's the y coordinate. That's our output. So 150 is equal to 8 40 times what? You have to figure out what that x is. And then when we talk about Jada, we use her equation, y equals 7x. And we know $150 is equal to 7 times what? Find that value. Finish out, show your work to explain your reasoning, and then give me a response. We are going to be okay to count the half hours in this, so go ahead and round this to the nearest tenth to be able to get the closest value. That's it for our first example. Second example, Han and Claire have summer job stuffing envelopes for two different companies. Han earns $15 for every 300 envelopes he finished, and then Claire is earning right here. So how do I figure out these constant rates? Well, the first thing that we're after, let's talk about Han. Han is earning $15 for every 300 envelopes he finishes. We recognize over here that the number of envelopes is the input, the number or the amount of money is the output. So I need to be able to figure out K is equal to the number of dollars, or the amount of money is dependent on the number of envelopes. And what this will tell us as our constant rate is, look at this part B, the rate of change is going to be, what does it mean? The money made per envelope stuffed. Now you might be wondering, what do we mean by stuffing envelopes? Well, it means that there's some companies out there that they actually pay other people to put their mail and stuff inside of envelopes and then mail it out for them. So the printer will print it, they deliver it to the mail company or the stuffing company, they fold it, stick it in the envelope, and mail it out for them. They pay people to stick, as many envelopes as they can get done. That's how much money they make. So these guys are getting paid a certain amount for every single envelope. So then the question is, what about Claire? What would hers look like? Well, you have two options. You can do the amount of money for this first one, 40 divided by 400, or you can do 90 divided by 900. Either way, both of these will equal the same value. So they're both going to equal K, whereas his K is going to be just a little bit different. So who would make more money stuffing 1,500 envelopes? How much more money would they make? Explain how you know. If we just go ahead and simplify these, well, both of these right here, these K's, they equal 1/10. And this one over here, 15 divided by 300. Well, that one right there will actually be a little bit different. How many times does 15 go into 300? That's a pretty big question, right? 15 divided by 15 is 1. 300 divided by 15 is 20. So the question is, who's making more money? And what does that actually represent? What does that mean? And when we talk about the two of them, we have to decide who's earning more money for every single envelope that's there. We have to recognize how this translates into dollars. So 1/20th of a dollar is how much money. 1/10 of a dollar is how much money. Who gets paid more for the job? I want you to figure these last ones out. Final example is right here about Tyler. He plans to start a lemonade stand and is trying out different recipes for lemonade. He wants to make sure the recipe doesn't use too much lemonade mix, lemon juice and sugar, but still tastes good. So recipe 1 gives this as the equation, y equals 4x, where x is the number of cups of lemonade and y is the number of cups of water. So how his ratio is being mixed here. We recognize that that's 4 cups of what to what. Y is the cups of water that are going to be put out here. We can see this table that actually really helps us out because we see that x is right here for our input and y is the cups of water, as we learned from here. So we use the two together. If Tyler had 16 cups of lemonade mix, how many cups of water would he need for each recipe? Again, this one's up to you. Figure out what that rate of change is, what everything means. Finish all this up, and I'll see you in the next video with some homework help.